We have the equation f of x equals 3x squared minus x plus 8. And we want to be able to solve this equation using the quadratic formula, which I already have up here for us to take a look at it. And I've already told us that we have two complex solutions. The way I was able to determine that is by substituting into this portion of the quadratic formula. That portion is called the discriminant. And if I substitute in the values a, b, and c, I will find out that that is a negative value, and that tells me that I have two complex solutions. Now, where I get a, b, and c, I go to standard form, which was ax squared plus bx plus c. A is my leading coefficient, b is my secondary coefficient, and c is my constant term. So the first step is I identify a, b, and c from the equation. So in this case, a is going to equal 3, b is going to equal, notice I do not have a number there, so that's understood to be negative 1, and c is equal to 8. That's the first step. My next step, I'm going to substitute that into my quadratic formula. So x is going to equal a negative, and notice my negative b, or my b is negative, so negative 1 plus or minus the square root of negative 1 squared minus 4 times a, which is 3, times c, which is 8. And that's all divided by 2 times my a, once again, which is 3. All right, my next step, once I substitute, I want to simplify. So I have x equals, notice the negative, negative. That makes that a positive 1 plus or minus the square root of negative 1 squared is going to be a positive 1. And then notice I have a negative 4 times 3, which is a negative 12, times 8, which is a negative 96. All divided by 2 times 3, which is 6. Once I start my simplification process, I continue to simplify as much as possible. So my next step, x is going to equal 1 plus or minus the square root. And now I take care of this portion on the inside. 1 minus a negative 96 is a negative 95 divided by 6. Now I want to deal with the negative 95 under the radical. Whenever I have a negative number under the radical, that's going to give me what's called a complex number. So I separate the negative from it first. So I change it to 95 times a negative 1. And in the complex number plane, the square root of negative 1 is defined as I. So then I want to look at the number 95. And the factors of 95, I know that it ends in a 5. So I can divide 5 into it. So it's going to go 1 time. So it's going to go 19 times. 19 is a prime number. So I'm going to take this information. I'm going to put it back into my equation back up here. So x is going to equal 1 plus or minus the square root of, and I can't take the square root of either one of these, 5 or 19, so I'm going to leave it as 95. So the square root of 95i, because I took care of that with the square root of negative 1, all divided by 6. Now, I cannot simplify this any further, but I can split it out into two solutions. So I'm going to have x equals 1 plus the square root of 95i divided by 6, and x equals 1 minus the square root of 95i divided by 6.